everything is working. So hello everyone, good afternoon. My name is Alon Shikar, this is Moshe Tzagai, my partner. Both of us are architects. And we also teach at the Faculty of Architecture at the Technion, where we met while being students. During our day today, I'm running my own architecture firm. We do mostly educational public building, and Moshe is teaching design, and he's also working for an high-tech company developing 3D solutions for the fashion industry. Space architecture is a relatively new field. It's intriguing in the sense that it connects between many different aspects of science. In the last semester, we have created a multi-faculty course in the architecture department at the Technion, designing and building a prototype of an analog habitat together with our students. I want to start with the same question that we asked our students during the first lesson, and I'm sure that most of you know the answer for the first question, what is the distance between the Earth and Mars? But as for the second question, I'm not really sure. It could be quite tricky, the answer. I hope that in the end of the lecture, you will understand it. So in our talk, we're going to briefly talk about three main topics. The first one will be I'm going to introduce the challenges, constraints, and considerations that we have to consider in designing this analog. After that, Moshe will explore the design of the habitat, of the first prototype of the habitat, which we call Hub 01, and few main design principles we took into account while designing it. Lastly, we're going to look for space analog habitat systems in Israel. So, as architects, we simultaneously deal with two main thematic challenges. The technical challenges, which relates to the function of the building, and also the relationship of the building with its environment, and the human challenges, which relates to the well-being of humans and their social needs. This include places that encourage you to communicate, interact, relax, and also have fun, real fun. Basically, a place that you can attach to and relate to, and promote a sense of community. On top of that, designing and building an habitat should also help the analog astronauts to feel that they're truly living in a different world. And this was, for us, this was the real challenge, to really make the astronaut feel that they're living in a condensed space and in another planet. A moment before we will show and Moshe will explain our design, this is a few of the challenges that we face and considerations. And so the mission itself could be supposed to be 7 days mission. It's supposed to be for 6 astronauts, between 4 and 6 times a year. And we're going to do several experiments, as just Hillel says. Our budget for the whole mission was around $15,000, around 50,000 shekels. And as for the time, you already know, we had to do it in 12 weeks, the length of the semester. For us, it was very important not to come with a pre-design concept for the habitat, and we wanted to explore and create it from the start with the student. It was a very difficult task for us. So we had to align them, we had to make a research, run ideation, prototyping, building models, lots of models, source materials, produce detailed work plans, and of course we had to build it with them and with several helpers from the outside. To sum it all up, we made a diagram that presents our research on the differences of existing habitats that we that Roy showed before, we chose to place our habitat under the dwelling and sustainable area, the right above. This decision reflects through all our design concepts. For example, it has to be reusable, deployable, and of course, for us, it must have a sense of community. I will hand it over to Moshe to show our design.
Hello, everybody. I'm a bit tired, like all of us, so I'll try to keep it fast and snappy. Okay. So this is our design. Let's see how we were able to meet our desires. So, as just explained, we wanted something that can be reusable, transportable, compact, upgradable, and low budget. These qualities can also make something scalable without compromising on structural integrity. So the perfect match for us was using a shipping container as our base module. After that, we explored different configuration of how this can be expanded into a colony and an ecosystem of habitats. We believe that this expansion to a colony or an ecosystem is very important to any future colonization attempts. At the level of the plan, we found a way to make 15 square meters into 50 square meters to accommodate all our programmatic needs. We made the kitchen area the heart of this building. This was done to create a sense of community, comfort. Basically, we want this to feel like a home, away from home. The multi-purpose area can be used during different times during the day. It could be a dining table, a meeting desk, and an extra working space. The sleeping pods, right there, were to provide the more private area, private spaces. We introduced a bit of shelving systems that can be individualized and make it more comfortable for each one of the analog astronauts. So astronauts experience the outside world only with a suit, a heavy suit. So their experience inside the habitat is even more important as the only place that they can actually feel free. We felt we needed to introduce lightness and warm luminosity into the space. The connection to the outside environment using light was something that we realized was lacking in most of the habitats that we researched. For the interior choice of material, we also was guided by our goals and choosing and opting to use textures that are a bit more warm or natural-like materials like wood or padded textured fabric to create something that is more warm and tactile, something that is less clinical and even technical sometimes. These are our students, our amazing students. A few of them are right here. And together with them, yeah, they definitely. So together with them, this is what they were able to achieve from design to building and habitat. Two students from computer science built a chat program to do the delay, a waste management system, energy production using solar panels. So 2020, our goal is a large-scale analog mission with the Austrian Forum. In our look into the future of this DMARS team initiative, we see this evolving to a space analog ecosystem, a colony at least 5 more habitats for academic research, education, commercial initiative. We believe that if we really want to someday colonize Mars and other planets, the human factor is the most important one, and we need to start exploring more complex human interaction, and this small step will give us a big leap forward. If you're interested to know more, you can talk to us right after we finish. Thank you.